Hello everyone. Today we're going to take a look at a practice page for dihybrid crosses. It's called the Chapter 10 Dihybrid Cross Worksheet. Alright, now just to review real quickly, a dihybrid cross is going to be where we're going to look at two traits for a particular organism, and we're going to be mating or crossing two individuals and examining two traits of how those are inherited. All right, so we'll look at that real quickly. All right, let's get started. The first question, the first information says, in rabbits, gray hair is dominant to white hair. Also in rabbits, black eyes are dominant to red eyes. These letters represent the genotypes of the rabbits. Okay, and so we've got gray. Ooh, I just can't take it. I'm gonna have to erase that. All right, and so we've got gray. Gray fur, which is represented by a G, and it says that gray fur is dominant to white fur. And so white fur will be represented by a little g, a lowercase letter of the same letter. So the dominant trait is represented by a capital letter, the recessive trait is represented by a lowercase letter. And then it says that the eye color, that black eyes are dominant to red eyes. So we're going to put a capital B for black eyes and a lowercase b for red eyes. All right, and so that is the letter information for our traits. Now, question number 1 says, what are the phenotypes? Remember that the phenotype is a physical description of the rabbits that have the following genotypes. So the genotypes are the letters, things like GG or BB. Okay, and so those are going to be our genotypes, 2 letters, and 2 letters for each trait. And then the phenotypes are going to be things like black and red. Now, 2 letters for each trait, but that would really mean that we should write it as GGBB, because we're looking at both traits at the same time, and so that might be the information representing one individual. And we would say that they're heterozygous for fur color and homozygous dominant for eye color. All right, so let's just look at the first one. It says, what if you have an individual that is heterozygous for fur color and homozygous recessive for eye color? What would that individual look like? Okay, well, since we do have a dominant trait, then the dominant gene will be expressed, and so it would have gray fur. But then the eye color gene, both traits or both alleles are recessive, and so we would say that it is going to be red. And so we would say gray fur, red eyes for that individual. Okay, let's look at the next one. The next one has little g, little b, little b. Okay, in this case we have no dominant traits, and so we have only recessive alleles, and so the fur color will be white fur. And the eye color is also homozygous recessive, same and recessive, and so we would say red eyes. All right, and so this will be a white fur, red eye individual. Okay, pause the video for a moment and see if you can do the other 2 there in question number 1. All right, and so the other 2 we had little g, little g, big B, big B. So homozygous recessive for fur color, so that would be white fur. And then homozygous dominant for eye color, and so that will be black eyes. And so this will be a white fur, black-eyed rabbit. The other one is heterozygous for fur color and heterozygous for eye color. And so it would be a gray fur, black eye rabbit. All right, and so that is how we do number 1. Let's look at number 2. All right, now number 2 says a male rabbit with the genotype capital G, little b, is crossed with a female rabbit with the genotype little g, capital B, little b. The square is set up below. Fill it out and determine the phenotype and the proportions of the offspring. And when you look at the page, this is what you have set up on your page. You have a 4x4 grid Punnett square, and then across the top you have these parental gametes, and across the side you have these parental gametes. Now the red ones came from the red parent, and the green gametes came from the green parent. And we'll talk in a little while about how you can determine which gametes, just to, not to spoil it, but just to give you a preview. It is going to be something called the FOIL method. Okay, so we'll talk about that in a minute, but not right now. All right, so we're going to fill this in. We'll fill that in by pulling that G down and moving this G in. Okay, and so we'll have, remember that we want to group the letters together so that we can tell about the dominant and recessiveness of the traits. And so we've got a capital G and a lowercase g, and we always want to put the capital first if we have one. Next we'll pull in the little b and the big B, and so that will be just like that. All right. Just to do one more, let's see. This one will actually be the same. Capital G from the top, a little g from the side, a capital B from the side. Remember, capitals first, and then lowercase b from the top. So those are actually going to match. Let's see this one. Big G, little b, little b. And so since we only have lowercase, we will fill those in like that. And then this one will also fill in the same way. All right, take just a moment, pause the video, fill in the rest of the squares, and then we'll check. All right, and so once you fill in your Punnett square, you should have the different potential offspring that look like this. And so now what we're going to do is we're going to count how many have a particular genotype or a particular phenotype. And so question number 1 says, how many out of 16 have gray fur and black eyes? Okay, gray fur and black eyes. Okay, capital G, so that's got gray fur, and capital B, black eyes. So there's 1. Okay, gray fur, black eyes, 2. Gray fur, black eyes, 3, 4. Capital G, capital B, gray fur, black eyes, gray fur, black eyes, gray fur, red eyes, so that one doesn't go in our count, and all the rest of these are gray fur with red eyes. Okay, so gray fur and black eyes will be 8 out of 16. Okay, or 1 out of every 2, or 50%. All right, Let's see what the next question is. How many out of 16 have gray fur and red eyes? Okay, so let's count gray fur and red eyes. Let's switch to a different color for this one. All right, here we have gray fur and red eyes. So there's 1, gray and red, 2, 3, 4, gray and red, 5, 6, gray and red, 7, 8. Okay, so at this point I've actually counted all of my squares, and gray fur and red eyes is also 8 out of 16, or 50%. And so all of my potential offspring have those two phenotypes. How many out of 16 have white fur and black eyes? Well, remember, white fur would have to have a little g, and none of my potential offspring have any little g colors, so that's going to be 0. And then how many have white fur and red? Well, we already said there are no white fur rabbits in this group. So even though there was a white fur parent, that gene gets covered up by the dominant gene and the dominant allele of gray. So there are no white fur rabbits in this litter. Okay. All right, so that is how we work number 2. Let's move on to number 3. All right, so number 3 says a male rabbit with the genotype G, G, B, B. So it is heterozygous for both traits. A male rabbit that is heterozygous for both traits is crossed with a female rabbit with the genotype, and she's also heterozygous for both traits. All right, so we have a heterozygous male for both traits and a heterozygous female for both traits, and it says the square is set up below. Fill it out and determine the genotypes and the proportions of the offspring. All right, and if we look, we'll see that this individual has these potential gametes along the side. And it turns out that we see the same potential gametes written across the top because they were both heterozygous. They were both, oops, that should be a lowercase g. I'll tell you what. And then that's a lowercase g, capital B, and a lowercase g, lowercase b. All right, and we'll talk in just a minute about how we determined those gametes. But the gametes, meaning I get one from each trait, one allele from each trait, one possible chromosomal piece of information from each trait, goes along the sides, and then we have potential offspring in the center. All right, so let's take a moment and fill that in. All right, and so this is what the fill-in should look like. At this point, let's go ahead and take just a moment and actually write down the phenotypes. Okay, so this is gray and black. This is gray and black. All right, gray and black, gray and black, gray, black, gray, black. Okay. All right, and so I'll tell you what, I'm going to change my mind and I'm going to look at the question and count. How many out of 16 have gray fur and black eyes? Okay, so gray fur and black eyes. Okay, that's all the ones that we just looked at. 1, 2, 3, 4, 5, 6, 7. This one is also gray and black, 8. This one is gray and black, 9. This one is gray and red, so that's a no. Gray and red, white, and the rest of these are white, so none of them will be. So our gray, fur, black eyes are 9 out of 16. All right. Next question says, how many out of 16 have gray fur and red eyes? Okay. Here's a gray fur and red eyes. So I've got to be looking for red eyes. I've got to be looking for a homozygous recessive on the B's. Okay. So so there's red eyes with gray fur. All those are white fur because I have homozygous for the white. And then there's gray and red. Okay, so gray and red is going to be 3 out of 16. Okay, I'm rapidly running out of colors here. Let's see. Let's try something like this. Okay. All right, and so I'm going to. My next question is white fur and black eyes. Okay, so let's find one that we haven't. Okay, white fur. So these are the only 4 left that we haven't already put into a category. And they all have white fur. This one has red eyes. So this one, and this one have black eyes. So at that point we have white fur, black eyes, and that is 3 out of 16. And the last question says, how many have white fur and red eyes? Okay, white fur and red eyes is going to be this one, homozygous recessive for both traits. And so white fur, red eyes, 1 out of 16. And 9 plus 3 plus 3 plus 1 adds up to 16, so we have indeed counted all of our potential offspring. All right, so that is how we work number 3. Let's see, let's turn the page to the back. Okay, and here's where the real fun starts. It says, show a cross between a homozygous recessive and heterozygous individual and a homozygous dominant and also heterozygous individual. Okay? And it says you will have to set this one up yourself. Okay. So we have to put our own gametes along the side and along the top of the square. And so that's going to bring up a question: how do we put those in there? How do we determine the gametes? I'm going to take our Punnett square away just for a moment. Let's see, what if I take that one away? There we go. All right. And so I'm going to take away our Punnett square just for a moment, and let's talk about this. I'm just going to focus on this individual right now. So let's say if I have capital or lowercase g, capital B, lowercase b. And so we are going to use what's called the FOIL method, which stands for first, outside, inside, last. First, outside, inside, last. And so what we're going to do, we need 1G and 1B for each possible gamete. And so what I'm going to do is I'm going to say, all right, if I had this G with this B, then it would make a little g, big B gamete. Now we're going to do the outside. What if I had this G with that B? Well, then that would make a little g, little b gamete. What about this G with that one? That's my inside. So first, outside, inside. Okay, and that's going to be little g, big B, and then last. And so that's going to be little g, little b. And you'll notice that some of these are the same, but that's because we had a homozygous parent here. All right, so that's going to be the gametes for that parent, and we'll put them on the side of the Punnett square in just a minute. You can go ahead and write those along the top if you'd like. Let's talk about what's going to work for this parent. Okay, FOIL, first G and first B. Outside, capital G, lowercase b. Inside, capital G, capital B. And last, capital G, lowercase b. All right, and so there will be our gamete possibilities. Again, these are possibilities. What happens if I get this one with this one, or this one with that one, or that one with the other one? And so that's just the possibilities of what could happen with our gamete formation. All right, so these will go along the side, these will go along the top, and then we'll be ready to fill in our Punnett square. All right, and we are finishing filling in capital G, lowercase g, little b, capital G, lowercase g, big B, little b. And our last set, which has two lowercase b's. All right. And so that is what the inside of the Punnett square would look like for number 4. And so that's all that we've been asked to do in that case. All right, let's clear the board. Number 5, an aquatic arthropod called a cyclops has antennae that are either smooth or barbed. The allele for barbs is dominant over smooth. In the same organism, non-resistance to pesticides is dominant over resistance to pesticides. Make a key to show all the possible genotypes and phenotypes of this organism. Okay, all the possible genotypes and phenotypes of this organism. Okay, and it looks like that they actually have your genotypes written down. Let's see, we don't need that for this one. And we're going to use our green. So capital B would be our barbed. Capital B, lowercase b, again would be barbed. And lowercase b would be a smooth antenna. On the other hand, a capital N would be a non-resistant capital N, lowercase n would be non-resistant. And then a little n would be resistant to pesticides. Resistant. All right, and so now let's look at one other thing. If I had a homozygous dominant genotype with a homozygous dominant phenotype, that would be one possibility. Homozygous with heterozygous, 2, 3. So there's 3 possible genotypes for the homozygous with homozygous dominant, heterozygous, homozygous recessive. What about, let's see, what if we had a heterozygous for antennae shape? It still could end up 1, 2, 3 possible matches for the pesticide resistance, and then the same thing is going to happen for our smooth antenna shape. 1, 2, 3. So you can see that there are a total of 9 different genotypic combinations. So 9 possible genotypes. What about phenotypes? Well, since barbed is one phenotype, smooth is another, non-resistant is a phenotype, and resistant is another. Okay, and so we could end up with barbed connecting with either our non-resistant or our resistance. There's 2 possibilities. And then smooth also could connect with either non-resistant or resistant. And so we have a grand total of 4 phenotypes. All right. And that's all that we're going to do with number 5. Let's look up number 6, 7, and 8, and that will finish out our time together. All right, number 6, it says a cyclops is resistant to resistant to pesticide. Okay, resistant to pesticide, that means it's going to be homozygous recessive in little n, resistant to pesticide, and has smooth antennae. Okay, remember smooth was recessive also, so that will be little b. All right, is crossed with one that is heterozygous for both traits. Okay, so heterozygous for both traits. And of course, that means that it will be non-resistant and barbed because those are our dominant traits. All right. So number 6 says, so show the genotypes of the parents. Well, here are our genotypes. There's the genotype for parent 1. There is the genotype for parent 2. I'm just going to label these genotypes as P1 and P2. All right, and you can write those down on your worksheet. All right, set up a Punnett square for the cross. All right, so we're going to, now this one can only provide, there's first, outside, inside, last, and you look and you can see that the only possible gametes it can provide is little n, little b. All right. Now, on the other hand, again, making our FOIL combination, capital N with the capital B, capital N with the lowercase b, capital N, capital B, capital N, lowercase b, lowercase n, capital B. Now in this case we don't put the capital first because we want to preserve the trait order. And little n, little b. Okay. And so now it is time to fill in our crosses. Take just a moment and fill those in. All right, and so we have our traits filled in, and you can check yours and be sure that they match up and that you have filled that in correctly. So we've got our gametes on the side, we've got potential offspring in the middle, and it says, what are the phenotypic ratios of the offspring? Okay, phenotypic means that we're going to talk about the dominant and dominant traits. So non-resistant, let's see, let's switch to a different color. Let's see, non-resistant and capital B, barbed. Non-resistant and barbed, and let's see how many of those there are. Okay, non-resistant and barbed, 1, 2, 3, 4. This is non-resistant and smooth, and all of these are smooth. Okay, oh, this is resistant and barbed. Okay, and then this is resistant and smooth. Okay, so it turns out that non-resistant and barbed, we have 4 out of 16. Now let's do non-resistant and smooth. Okay, non-resistant and smooth. Let's see, this one is definitely non-resistant and smooth, so we'll count it. Non-resistant and smooth, each of those. Okay, these and all of these are resistant because I'm homozygous recessive for all of these possible offspring. So that is 4 out of 16. Okay, now let's talk about what if we had one that was resistant and barbed. Okay, well this is resistant, homozygous recessive, and it's barbed because it has a dominant gene. And I see 1, 2, 3, 4 of those. So again, 4 out of 16. And then what if I have one that's resistant but smooth? Okay, resistant and smooth, and we will see that's going to be homozygous recessive, which happens to be these 4. So again, 4 out of 16. Okay, and so it turns out that each of our phenotypic possibilities is 4 out of 16. All right. Let's see, I'm going to look at the next page. Okay, so there are some additional dihybrid practice problems on the following pages. Just use the same steps and work your way through. I hope you have a great day, and I hope this was helpful.